everyone, in this video we are going to be talking about left and right hand limits. So before we start talking about that, I just wanted to do a quick recap of what we talked about in the last video. So last video we talked about how to find limits, and I have this example right here that we're going to go over just to remember what we did. So here we have this blue function f of x, and we're being asked to calculate the limit as x approaches 3 of f of x. So like we did in the last video, to figure this out, we're going to trace our curve. And as we get close to an x value of 3, we're going to look and see what the y values get close to. And it looks like the y values are getting close to 6. And then same thing as we trace from the right, we're going to look and see what our y values are getting close to. And as x approaches 3, it looks like the y values are getting close to 6. So we would say that the limit as x approaches 3 of f of x is 6. So you might be wondering, why do I bother tracing my curve from the left and the right? Maybe it's obvious to you that as x approaches 3, our y values are approaching 6. And in this example, it does seem kind of simple, but we are going to see an example where it actually does matter if we trace from the left and the right. And that's going to be the idea behind left and right hand limits. So let me show you an example of that. We have a new function g of x, and it looks kind of weird, right? We have this big jump in the middle, and that is going to make a difference, when we're calculating this limit. So they're asking us to find what is the limit as x approaches 4 of g of x. So let's try to use our same technique that we've been using. So if we start tracing this curve from the left, as x approaches a value of 4, it looks like the y values are approaching 3. Okay, as we approach from the right and we trace our curve, as the x values approach 4, it looks like our y values are approaching 7. So that's kind of weird. In all the other examples we've seen, as you approach some x value, the y value gets close to the same number, whether you trace your curve from the left or the right. But this time, we get a different answer. If we trace it from the left, we get a y value of 3. And if we trace it from the right, we get a y value of 7. So what do we say then for this limit as x approaches 4? Do we say 3? Do we say 7? Do we say neither of them? And it turns out the answer is actually that this limit does not exist. And then we often abbreviate that as DNE, does not exist. So we actually can't put an answer down. This limit doesn't exist. And the reason for that is because it's not clear if we should pick 3 or 7 as our answer, right? We get it, depending on which side we approach it from, we get a different answer. Therefore, there's no objective way that we can decide whether the answer should be 3 or 7. So this limit doesn't exist. But what do? Do we just give up and hope we never have to do limits when we have functions like these? But we don't have to completely give up, because we can still talk about something called the left and right hand limits. So that's what I'm going to introduce now. So the left-hand limit is exactly what we were just talking about. It's if you trace the curve from the left, what do the y values approach? And then the right-hand limit is if you trace the curve from the right, what do the y values approach? And so we actually have special language and notation for this, which I've written here. So this little plus, if you put a plus next to the x value you're approaching, that means we're talking about a right-hand limit specifically. And then if you put a little minus next to the x value you're approaching, that means we're specifically talking about a left-hand limit. So even though this weird function g of x doesn't have what I call an overall limit, even though this right here doesn't exist, we can still talk about the limits from the left and the right. Those are still things that exist and are perfectly valid. So let's try to figure out what the right-hand limit is. So as we approached our curve from the right, it looks like our y values were approaching 7. So that is going to be our right-hand limit. And then as we trace our curve from the left, it looked like our y values were approaching 3. So that is going to be our left-hand limit. So even though we didn't have this overall limit, it didn't exist, we can still talk about these left and right hand limits. So let's do another example. Here we have this function h of x, and again, it has this weird jump, but luckily we can still talk about its left and right hand limits. So let's calculate the right-hand limit first. So what are we going to do? We're going to trace our function starting from the right. So as we trace it starting from the right, as x gets close to 2, what do the y values get close to? And it looks like the y values are getting close to 2. So that is our right-hand limit. Now for the left-hand limit, we start from the left, we trace our curve, and as x gets close to 2, what do the y values get close to? They get close to 10. So that is our left-hand limit. And now, what about this one? What about our overall limit? Does it exist? Well, our left-hand limit, our right-hand limit is 2. Our left-hand limit is 10. Those numbers aren't the same. They don't agree. So that means that our overall limit is D and E. It does not exist. These two numbers would have to be the same number in order for this overall limit to exist. Because they're different numbers, that overall limit does not exist. And then I also want to make a note, this term overall limit that I'm using to refer to this, that's not a technical math term. That's kind of just a term I use because I think it makes sense, but just know that if you go looking for that term in a textbook, you might not find it. One thing I do want to point out, because I anticipate you might have a question about this, is you might be looking at these holes right here, and you might notice that the hole on the top is open and the hole on the bottom is closed. And you might be wondering, does that affect our answer for the limit? Does it matter? And for example, on the last problem, the top one was open and the bottom one was closed. But the answer is no. It does not matter which one is closed and which one is open. When you're calculating the limits, you'll still get the same answer. And that is because limits don't ask us to evaluate a function at a certain point. They just ask us, what do the y values get really, really close to? So that does not matter. And then one warning that I want to give, because I could see this being a point of confusion, is to not confuse these notations. So the one on the left, this is saying calculate the limit of f of x as x approaches -2. However, this one on the right is saying calculate the limit of f of x as x approaches 2 from the left. Okay, so those are not the same statements, even though they kind of look similar. Okay, so this is a -2, whereas this one's a +2, but it means approach from the left. So just keep that in mind because they kind of do look the same. So hopefully that video was helpful for you. We are going to be doing some more examples in further videos and going over some limit properties. So make sure to check those out. And as always, leave some comments if you have any questions, and don't forget to subscribe. Thanks.